Okay, good morning class. So today we're looking at exponential and log functions. Looking at the examples for exercise 3. No, 4. Examples for exercise 4, and exercise 4 is on page 54, correct? 50? The next part. Yep. So we're going to look at logarithmic functions. We define a logarithmic function as y is equal to log x base a, where a is greater than 0, a is not equal to 1, where x is an element of r. In unit 1, you introduce the graph of y is equal to x base 2 or x is equal to 2 to the y, as the inverse of y is equal to 2 to the x. Key features of the log function: all graphs of the form y is equal to log x base a, where a is greater than 0, which means to say positive, and a can't be 1. X can be 1, but a can't be 1. Okay, so that's the new denominator. The reason for that is because log x base 10 or log x base anything other than infringing on the restriction will give you an answer of 1. Log of 1 is always 0. Okay? Because if you look at the log graph, remember, that's what the log graph looks like. And log of 1 is 0. Now, coming back to this here, we say now log x over log a. Now, if a is 1, what is log of 1? 0. And 0 can't be in the denominator. Okay, that's why we always say a can't be 1, where x and a must be positive, where x is an element of all real numbers, and these features. The x-intercept is 1 and 0, the y is a vertical asymptote, the domain is x is greater than 0, and the range y is an element of all real numbers. A is greater than 0 and then 1, which is positive, the graph is increasing. And if it's negative, if it's between 0 and 1, the graph is decreasing. When you're comparing the log x base a and y is equal to log x base 1 over a, you can see that the two graphs are reflection in the x-axis, and that's we spoke about often. Okay? Why? Because this graph can be written as what? Negative log x base a. And in comparison, what do you see? It's a negative there. Okay, and that is why it's reflected in the x-axis. What's the rule if something is reflected in the x-axis? Y becomes negative. Okay, now we're looking at the example on page. Sorry? Example page 54. Okay. Thank you. So here we are told that use a table to plot the graph of y is equal to log x base 2 or x is equal to 2 to the y. So this is the one graph we need to draw. And of course that is the other one I'll highlight it in blue afterwards. On the same system of axis, the graphs are drawn on the next video. Okay. So people, I don't have time to remember all of these rules. Okay, you girls are a bit different, much younger. So what happens is I draw the inverse, the table for the inverse function. Okay, so what I do is I say the inverse. What's the inverse of this graph? It's going to be x is equal to log y base 2. So in other words, the inverse graph is 2 to the x. Not so. So what I do is I draw a table. That's an x and a y. It's minus 1, 0 and 1. If I put minus 1 in here, I get put 0 in, I get 1. Put 1 in, I get 2. But what's the question to draw this graph? No. So the graph I must be drawing is the log x base 2 graph, which is x and y it's going to be a half, 1 and 2, minus 1, 0 and 1. So that's the graph. And then y, x. So it's 8, 1, 2. It's half and minus 1. 0 and 1 and 1 and 2 and 1. There's your logarithm. Okay, you guys understand? That's one way of doing it. Otherwise, what you can do is, I could have also said, okay, because I know it's an inverse function. And we know this is going to be minus 1, 0 and 1 for the inverse. To the exponential graph that we normally draw. Not so. So what I do is I say, okay, y is now minus 1. So minus 1, or we can say, using this formula here, x is equal to 2 to the 1. So if y is minus 1, it's going to be 2 to the minus 1, which is half. On the other end, we've got y is to be 0. So 2 to the 0 is 1. And then the next one is y is 1. So it's 2 to the 1, which is 2. You can draw that graph as well. You guys understand? So either or, you should get the full one. Okay. See any confusion there? Alright, so let's look at this graph here. I'm going to apply the second method first. So we draw the table. We draw minus 1, 0 and 1 on your y. So it's a log function, the inverse to what we normally expose to. So we say x is equal to half to the 1. So if y is negative 1, so it will be half to the negative 1, which is 2. You all agree with that? So we say x is equal to half to the, what is y now? 0. And half to the 0 is? You got the half to the 1, which is? Okay. So if x is 2, y is negative 1. Okay. I don't care if there's actually no if on the board. We're supposed to have labeled this. Y is equal to log x base 2. I should have written it. Okay, not if. So we got 2 and negative 1, then we got 1 and 0, and we got then half and 1. What do you notice here? The graph is decreasing. But what we also notice about these graphs, this graph is actually reflected in the what? X-axis. Yes, can't you see it? This part here falls exactly onto this graph, part of the graph. And it's not making an omen, it's like a different shape. This part of the graph falls exactly onto this part. Okay? And if you also do the comparison here, what do you notice about these two? I can rewrite this, it's going to be x is equal to half, 2 to the minus 1. And when do we go from y to minus y? When we change y to minus y? Reflection in the x-axis. You see that, people? Okay, so this on page 55. 54 or 50. So with that, you should be able to do exercise 4. In exercise 4, let me just check what I've highlighted here. Exercise 4 is 1.1 and 1.3 and 1.1, 1.3 and 1.5 for exercise 4. Okay. So that's your homework for tomorrow. Including of, you'll move to the next lesson.